today we are going to be looking at product rule. Now when we are talking about a product, we are talking about multiplication of two objects, multiplication of two numbers. Let's say you have 2 times 2. This is a product of 2 times 2, which is going to give you 4. But now, what if you are to differentiate a function? What if you are to differentiate a function that the two functions that are multiplied by each other? Let's say for instance you have y to be equal to a product of u and v. Y to be equal to the product of u and v. So here we are going to have that y prime, which is equal to the y dx, is going to be equal to u dv over dx plus v du over dx. This is known as the product rule. This is known as the product rule. Now let's take some examples on this rule. Let's say you are to be given a function that y is equal to, this number 1, y is equal to x plus 1 to bracket of another one, 2x minus x. So you are to differentiate this function. Now here you are going to take u to be equal to x plus 1. So du over dx is going to be equal to what? Du over dx is going to be equal to what? This is going to be equal to 1. Then let's take v to be equal to what? Let's take v to be equal to 2x minus x. Now dv over dx is going to be equal to 2 minus 1. Is going to give 2 minus 1, which is equal to 1 as well. Alright, so this is what we have. So now let's use this and substitute it in this formula. Now y prime, which is equal to dy dx, is going to be equal to, this will give us u. You put u and multiply with dv. So we have u here to be what? X plus 1 multiplying dv, which is 1 dv plus dv. This is dv, which is equal to 1. So this is going to be plus dv dx rather. V now, v we know it to be 2x minus 1, so minus x multiplying du. Du is what? Du is also equal to 1. So this is what we have. So if you multiply this, we are going to have x plus 1 plus 2x minus 1. Sorry, minus x. 2x minus x. So this is going to be equal to, this is x here, this is minus x here. There we go. Then you have 1, is going to be 1 plus 2x. So this is your y prime. This is the y dx. It's going to be equal to 1 plus 2x. Alright, let's take a second example. Example 2, where you have x raised to the power of minus 2 into the bracket of 15x squared plus 5x minus 1. You have to differentiate this. Then y prime is going to be equal to, now I would not like us to use this long method again because we have done this, so I believe by now you should have known how to do this. Now I'm going to show you a shortcut way of doing this. A shortcut way. You don't need to use this formula like this, the way I've used it here, but I'm going to show you a very perfect shortcut way to do this. Alright, now I would like you to follow me now. So we are going to differentiate this function first. You understand? We differentiate this function first. Now product is, there's something called commutativity where a times b is equal to b times a. So as well, this formula you could differentiate v before differentiating u and add it with u times dv. So this is commutativity. So multiplication is commutative. So it doesn't matter what you differentiate here first. You could differentiate this one first and keep this one constant, and after differentiate this one and keep this one constant. So let's try that and see. First of all, we differentiate this. We are going to have minus 2 x raised to the power of minus 3 take this one to this side, this minus 2, minus 2 minus 1 is going to give minus 3. So we are going to keep this one constant, 15x squared plus 5x minus 1. So this is going to be plus. Now we keep this one constant and differentiate this. We are going to have x raised to the power of minus 2 into, if we differentiate this, we are going to have 30x plus 5. This one here is going to give us 0. So this is what we have. So now let's simplify this now. So now this is what you have here. So this is going to give you, you could choose to open the bracket further, or you could choose to leave it this way, but let's open the bracket further depending on what you saw of the option. But I would advise you to reduce it to the nearest form, and I think this is where it ends, because if you open it here, it's going to be too bogus. So this is your answer. So let's look at another example. Let's look at the example 3, where you have to differentiate exponential x sine x. Let's differentiate exponential x sine x. Now this leads us to differentiation of exponential. If I do differentiate exponential x, now if y is equal to exponential x, y prime is also equal to exponential x. This is what we have. If y is equal to x, y prime is also x. If y is equal to exponential x, y prime is also exponential x. So now if we are to differentiate this, we are differentiating exponential first, keep sign constant, plus differentiate sign, keep exponential constant. So let's do this. We are going to have exponential x, keeping sign constant, then this will be plus. Now keeping exponential constant and differentiating sign, you are going to have exponential x cos x. So now we are going to factorize exponential outside there. We are going to have sin x plus cos x. So this is your answer. Quickly, let's move to the next example. Example 4, where you are to differentiate 6x raised to the power of 3 cos x. This is also a product rule. So this is going to give us, we differentiate this first. 3 times 6 is going to give you 18x raised to the power of 2 cos x plus, you now keep this one constant, differentiate this, then that's going to give us minus sin x multiplying 6x raised to the power of 3. So let's make this way. You know that this 6 and this 18, you have common terms there. You can put 6 outside, then this you can put 6x squared outside, and this will reduce to what? This is going to reduce to 3 cos x minus sin minus x. Sorry, we are going to have minus x sin x. So this is our answer. This is our answer for this. So let's look at another example 5. Let's look at another example 5, where you have cos x sin x, cos x sin x. So now to differentiate cos x sin x, we are going to have y prime to be equal to, if you differentiate cos x, we are going to have minus sin x, then you put sin x constant, which is sin x, then plus differentiate, put the cos x constant, cos x, differentiate sin x, you have what? Cos x. So that means y prime here is going to be equal to minus sin square x plus cos square x. So this is what you have. This can also be rewritten as cos square x minus sin square x. So this is what you have at this point. This is what you have at this point. But it is also important to know that under trigonometry identity, cos square x is equal to 1 minus. Alright, so let's let's look at example 6. Example 6, let's say you are given x raised to the power of 3 cos 5x, x raised to the power of 3 cos 5x, and this is equal to y. So now y prime is going to give us, we differentiate this first, keep this constant, and differentiate this and keep this constant. So if we differentiate x raised to the power of 3, we are going to have 3x raised to the power of 2 cos 5x, then plus, if we differentiate this 5 cos 5x now, if we differentiate cos 5x, we are going to have x raised to the power of 3 multiplying 5 multiplying minus 5 sine 5x. So this is what we have. So let's simplify this. We are going to have 3x raised to the power of 2 cos 5x minus 5x raised to the power of 3 sine 5x. So you can also factorize x raised to the power of 2 outside there. We're going to have 3 cos 5x minus 5x sine 5x. So this is what we have as y prime. Y prime is equal to this. So we have 6 examples on product rule differentiation using the product rule. So please, I would like you to subscribe to this YouTube channel and hit the notification bell to get notified each time we post a video. Thank you.